Hey everybody, this is Larry. This is day 21st of the August Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's problem. Oh no, it's Sudoku solver. Okay. To be honest, I wrote a really optimized version of relatively Sudoku solver like maybe a long time ago. It has been a while though, to be frank, maybe even like a decade. So I don't remember if yeah, so I'm probably gonna just do the normal what's it called, branch and bound, and then kind of see if that's fast enough. If it's not, then we'll figure out what to do. There is a lot of what's this I for? There is a lot of literature about the Sudoku solver, so I'm not gonna really do that much explaining. If you want to search something, I think dancing links is the recommendation by Canoe. Um, but I haven't touched that in so long, like maybe literally a decade. So I really don't know if I am able to do. So I'm not gonna do that one, but I am gonna try to do as best as I can the Python brute force solver. So let's, without further ado, uh, so yeah. So I mean, this is just backtracking. It's just me trying. Okay, let me put in one, then put in two, dot dot dot. So it's just about kind of try to figure out how to do that in a smart way. So okay, so let's get started. Okay, so okay, how do I want to get started? This is gonna be fun. There might not be that much of me explaining because I think every like it is just backtracking, which is another way of saying recursion with a lot of tracking. There is going to be only one solution, so yeah. I mean, it's a little bit awkward because this can be as bad as the test cases that they give you, but we'll figure it out. We'll play around with it. Modify the border endpoints is kind of silly though, but but it's fine. Okay. Uh, okay. I mean, there are a lot of ways to do it, but I'm just gonna um, just thing. I guess n is equal to 9. Okay. And now let's just do. Okay. So then now we keep track of each row, column, and whatever. And maybe this time we'll use a bit mask. Yeah. Okay. I guess I could have done it here in the same loop. And here, else number is equal to port of xy minus just the int of this, and again we'll just minus 1 so that it re-index from 0 to 8, and then rows, this is x row. Wait, did I mess this up? Oh yeah, no, this is right. This may be a little bit of a boring video, to be honest, and I apologize for that, but you know, this is what this is. Which box is this? So 0, 1, 2, 3, 4, 5, 6. So how do we want to map this box? I forget how this goes. Oh yeah, so I guess x divided by 3 and y and 3 is equal to the coordinates, and then you times. Now we want to convert this such that each row is, so that's the box coordinate, right? Yep. Okay. So then now to convert that to number is just one of these times 3, right? What do we want to do? Rows times 3? Yeah, okay. Makes sense. Oops. Okay. So now we set up the constraints, and then now here's the recursion, right? Okay. Let's just call it. I don't know. Naming things are hard. I usually just type Go for that reason. It's not a great name, but it's just what I do because I want to focus on solving the problem and not naming things. Then we have index. And that's good enough for me, I think. Yeah, okay. Hey, then we're done. We're good. Assuming that we check before. Do we check before or do we check after? I guess it doesn't really matter. So let's no, we should check before. So that means that, okay. And then we have, let's just say answer is equal to none. Let's just we'll figure out how to update the board thing later. Maybe we don't have to. We'll figure it out. Okay, let's just do this for now, and then we'll see. And then here, okay, current xy is equal to care of index x. This is the cell that we care about, and it should be a period. So yeah, so then we want to go index plus 1 is the recursion, but now we want to try for the next number first. So let's just go for a temp maybe in range sub from 0 to 8. And then what happens if row sub x and we'll have to do something about this part, but that's fine. Okay, so if this is good, so box is equal to then we want to do this recursion. Oh, attempt. What it should, okay, fine. This way, but yeah, sorry. Usually I solve these live, as you can see. I usually say that, but this one's been going on for a long time. So I usually solve these live, so it's a little bit slow. Watch it on 2x or whatever you need to do. This is clearly going to be an implementation problem, and it's clearly going to take a while. So settle down and settle fun, have fun, and then we'll see what happens. Yeah. You could also do an and not on the other thing. Yeah. Except for if found, we return. I think that should be good, but maybe just in case. And then now we was it board of xy is equal to string of attempt plus 1. I guess we can make this back to a period just in. No, I don't know. I don't know if this is good, to be honest. Because usually I don't like doing it in place, but we'll at least kind of see if this gives us a relatively responsible answer, and then we'll see. And you could plug this into your Sudoku checker and the other one, I think. Though I guess we can also do a show diff to kind of see. I mean, so I guess for this one it looks good, but again, it's going to be about the running time and stuff like that. So I don't know if this is fast enough, but let's give it a submit. Just, I'm not confident this at all. There are potential typos, but we'll see. Oh, wow, okay. That's actually surprising, to be honest. I was expecting, when I saw this problem, I was expecting to spend all night on this, but I guess, and maybe thankfully, like I said though, this problem depends on the test cases, and they can make the test cases as complicated as they want. So this is kind of, just means that the test cases are a little bit on the easier side, which I am thankful for because I don't really want to spend all night on this problem. But yeah, in terms of complexity, this is tricky. I don't know for this exponential exhaustive search stuff. I always find it a little bit tricky to analyze it because there's the exponential solution, but there's also a lot of inherent branch or bounding that is in the constraints of the problem, which I always find a little bit tough. So I don't know what to tell you. But there is, that said, a lot of literature on this, so I definitely recommend just looking it up. I don't know if I recommend this as my solution, as a good solution, but this is my solution. So, you know, take a look at this. This is just to go over the solution real quick. This is just a setup. This is the basically the rows. For each row, what numbers we use. For each column, what number we use. For each box, meaning one of the, you know, 3x3 boxes, what number we used. And then here we just kind of pre-fill the constraints that we have, and here I just kind of pre-process going from left to right, from top to bottom, all the spaces that we have to care about. There's actually a smarter way to do this, but I was just, you know, I was thinking about crossing that bridge when I get there, and thankfully I didn't need to. But in this case, yeah. And in this brute force, I just basically go for it one at a time, each empty space at a time. If we reach the end, then we're good. We set found is equal to true, then we return. Otherwise, we look at the current cell that we're looking at, including figure out the box, and then just brute force a number from 0 to 8, which we convert from 1 to 9. And here we gave it a try. So basically this is saying if this number is not used in the row, column, or the box, or an and of those three things and together, then we just OR it. Otherwise, we do a recursion on the next. So if it's good, then we set this to the cell. Otherwise, we go to the next cell. Actually, then you go to the next cell. Otherwise, you just try the next number. And this is recursion. This is flipping it on to true. This is flipping it to false. If you're not familiar with bitmask, I'm going to go over it in another video because I think I go over it a lot. So if you find another video on bitmask that I go over, I actually go over it a lot. But yeah, that's all I have for today. Stay good, stay healthy. Have a great weekend. So hope you do the contest with me later on. I'll see you later. Have a good night. Bye bye.